Welcome to Unite Now, where we bring unity to you, wherever you are.
Hi, everybody. Welcome. It's awesome to have you all here. Welcome to Meet the Devs. Today, we're doing a deep dive into the assets from the amazing Heretic project. And today, I have with me Adrian and Lasse from the Heretic demo team to talk to you all about the brand new packages that were released for the Digital Human and the VFX Character packages. Really awesome to be here with you all today. We're so excited to share kind of, what we love about these packages and why they're awesome. But before we begin, all of you are here to meet our devs. So let's start off with Adrian. Hi, Adrian.
Hello.
Hello. Why don't you tell everybody more about yourself?
Yeah, definitely. So, hello everyone. My name is Adrian. I'm a technical artist at the Unity's demo team. I joined these guys a year and a bit ago to work on the Heretic. And before that, I had a small indie development studio. Before that, I worked at a few other game development. And even before that, I worked in post-production. So I started my career actually in post-production 17, 18 years ago and transitioned into real-time in 2009. For the Heretic, I mostly worked on Morgan and a few other smaller things, but mostly Morgan and all the effects related to Morgan that are not necessarily the character itself, but some other stuff around him that are happening. And yeah, it's great to see so many people from all over the world, especially during these Corona times where you cannot travel. It's great. So thanks for joining.
Really is the best. Thank you, Adrian. Lasse, hello.
Hello, everyone. My name is Lasse. I am based in Denmark, and I'm a senior software engineer on the demo team. I joined Unity a little bit more than a couple of years ago, also in context of the Heretic, which was starting development actually a long time ago. And prior to joining Unity, I was at a game company called Pedersen, and before that, I was in a couple of other small game studios, always doing programming, but it all in a wide variety of fields within programming. So I suppose you can call me a generalist of sorts. Before that, systems programming, not games related. It's great to meet you all.
Thank you, Lasse. Again, thank you both so much, Adrian and Lasse, for being here with our community today. This is a really awesome opportunity for all of us to just like talk together about how awesome these the work that you've been doing is. And to kind of get started with that, I would love to talk more about the Digital Human package in particular. So while we discuss, I want to put some links up for folks so they have some context as to what we're talking about. But the first thing I want to start out with is I really want to know more about one of the big differences between the Digital Human package and the original Heretic project. Now, Lasse, when we were speaking, you were saying how the Heretic has been in progress for many years, and at the time, a bunch of the HDR functionality that was needed had to be kind of added in through custom extensions and scripts and such. But in the Digital Human package, everything runs off vanilla HDRP, which is fantastic. Can you tell us more about what changes happen between the workflow originally using the Heretic and in this new package? What are the differences that people should be aware of, and how are they reflected in the package?
It will be a bit of a long answer, I guess. I want to preface it by saying that I primarily worked on the human for the Heretic. To answer your question, when we started out making the Heretic and prototyping the visuals for the human and also other effects in the film, HDRP was still in a preview stage where it did not have several features that it has now for extensibility. So what that meant for us was that you face a problem or you face an idea, which then for the programmer becomes a problem, and it's like, okay, how do we get this interesting new effect into into the project. And HDRP was lacking some general features for extensibility at the time. You could not open shader graph and make a custom material, a custom shader using shader graph, for example. You also could not inject a custom rendering pass during the frame. Another thing that you can do now with the custom pass API. So there were some pretty big, I wouldn't call them stumbling blocks, but there were some challenges to actually extend HDRP with custom additions, which you often need in a project at the time, which was also understandable because the focus was on getting the core of HDRP solid and then moving on to the extensibility features later on. When we started building the Heretic, we didn't have them. So we were kind of forking the materials in HDRP. We were writing our custom shaders that way, and to inject custom commands into command buffer and stuff like that, we would just change the code in HDRP. We would fork HDRP itself, and that would then live in the project as a customized version of HDRP. Now, when you do something like that, you are going to pay the costs of doing that in increments again and again, because as every new version of HDRP got released, or every time we pulled it from trunk, then we would have to migrate all of our custom changes into that new version. And as the project grew, so grew the amount of changes and customizations, which then added a considerable amount of work for ourselves, really, in the project. One of the primary goals when we set out to release the human package as a standalone thing was to transition all of those customizations for at least the digital human into a form where they would be using the new extensibility features of HDRP rather than relying on the customizations that we needed earlier. And some of these transitioned really quite easily, and we were able to use shader graph for some of the materials, and we were able to use the custom pass API for other things that we were doing, such as the tier line. And then the HDRP team also helped us out, of course, on this road by adding the iMaster node for the shader graph, which is feature compatible with the customized shader that we built for the Heretic. So this was really important to validate that can we now render the thing with a vanilla version of HDRP, given that it has matured since we started on Heretic. I hope that answers your question, Ashley.
It does. Thank you. And you mentioned a couple of things that I definitely want to know more about. So, but before I get into that, can you also just give an overview about what the workflow is and, what steps can folks take to create their own digital human?
Oh, so if you mean if you want to download the package and apply the stuff in the package to another character,
or maybe if what folks can when they open the package, like what should be like the first things that they should check out, or maybe what are ways that they can apply parts of the package to projects that they're working on.
Right. So there's like 3 groups of features in the package. The first group is related to facial animation. There's a couple of systems in the package for importing 4D capture data and basically baking out nice clip assets that you can drop into a timeline and blend and play back on the face mesh. And then there is another group, which is the only real system in there is the attachment system, but the attachment system is necessary when you have animation that's driven by something like a 4D capture setup. Then you will want to be able to resolve all the secondary features of the face in a meaningful way. The attachment system provides that functionality, and that's what drives all the thousands of hair, little stubble and other hairs on the face, as well as some logical markers. And then there is, of course, the third group of features, which is all the shader graph and related rendering features. For actually, you could say that would be the easiest group to apply in any other project. By importing the package, you'll be able to create a material and use the digital human skin shader, and then drag and drop the inputs for that one. You would also be able to create your own eyes, not your own eyes, but virtual eyes, and use the eye shader that we have in the package to make those in the same way that we have done for the character and the heretic. And the same is true for the other shaders we have in there, specifically for the face.
Nice. I love that, because I think one thing I've seen, being asked in the community is, hey, I'm an indie developer, or, I don't have access to creating 4D scans. Can I still use this project? Are there still things of benefit? And I think you were kind of just hitting that nail on the head. There's so much there that you can use, whether you want to use the attachment script, if you want to use like the eye shaders, like you can grab all of that, kind of like no matter what your background is or no matter what you're working on, and find kind of really fun ways to apply it to your projects. Now, kind of going into that, especially because I was really impressed with what I saw and what was added for Gwen's eyes. So you had mentioned that there's the eye master node that we could use in our digital human package. If you could tell us more about that, and also there's a bunch of cool, nifty new gizmos available through the iRenderer script as well. So I'd also love to know more about those too.
Yes, I can start talking a little bit, and then I can share my screen afterwards and show the gizmos.
Great.
So I want to backtrack a little bit. So the eyes that we built for the heretic using the custom shader approach back then, the initial work for that was done by one of our colleagues called Nicolas Pancacchio. What he did was come up with a model for how we would do the lighting of the eyes. So the eyes are a 2-layer material where the surface layer of the eye geometry gets to tell like what's the specular intensity of the lighting, and then the lower layer, which is the iris and sclera, they get to evaluate what's the diffuse lighting intensity of the surface. And he also came up with a way to model the occlusion where the eyeball meets the eyelid. The reason that I'm isolating these things is that some of that went into when we then transitioned the digital human custom shaders into the package using standard HDRP features, etc. The analytic occlusion stayed in the package, and the split lighting model for the eye specifically went into HDRP thanks to an effort by Sebastian Lagarde and a team at a Hack Week, an internal company event last year, where people suddenly had a bit of time on their hands to actually take this code and transition it into HDRP to become part of HDRP. The material in the package now uses shader graph, and some of the custom features remain in the package, while others are now in HDRP as standard ones. Let me just share my screen. So I have the project open here. I hope you can see my screen. And the eyes are located. Let me get rid of zoom. Are located quite deep in the hierarchy. This is just some decision made in DCC by an artist, creating that space that feels nice for them. There's no real reason it couldn't be somewhere else. When we look at the eye, if we get rid of the rest of the head, some of it, then we can see that the eyeball is actually, most of it is in darkness. And so this darkness is a result of the occlusion evaluation function that is driven by markers on the skin. Ashley, you wanted to know something specific about these gizmos, so I can just explain them generally. So the eye shader expects a piece of geometry that is a single mesh, and given this single mesh, we want to do something with the textures that we're putting on the eyeball. When we look at the eye, we can make the lighting conditions here aren't great. I guess I could throw in an extra light. Okay. When we look at the eyeball, then let me select it again. Yeah. Then we can see that there are these gizmos that surround it. And these gizmos are can be used to control how the textures are mapped onto the geometry. There's a couple of them that are relevant. The first one is, imagine you're looking at the eye straight down. We would like to control how the texture is mapped onto that geometry just straight on. And that's what that is for. Some of the others are a bit more interesting. We have a cutoff point at the side of the eye where we decide where the cornea starts and where the iris plane is, somewhere in there. And that's the red bar that you see here. And you can kind of move that, and it's going to change how the rays are calculated within that space, within the cornea. And there's a couple of other markers like that that control something about how sharp the intersection is between this cutoff point and the cornea, so you can kind of smooth the transition by increasing this space here. And then there is a third one, which I actually can't remember what does right now. So let's just try. Oh yeah, it changes the offset of the iris from the cross-section offset. So yeah, we added these gizmos just to be able to actually for people to be able to use this stuff without typing numbers endlessly. And it's just a nice visual aid to be able to apply this this eye shader on top of new eye geometry. Let's say you don't want to use the geometry from the Pedersen package. You can roll your own, and then you can apply this tooling on top of it and get a different expression.
Awesome. Thank you for showing us that. I have another question, and actually you're kind of right almost in the perfect area, and someone else was asking about this in the chat as well. So, we've been hearing users from the community ask often about Gwain's hair. And I know it's a different case specifically for the eyebrows than it is for his head and scalp. Can you tell us a bit more about how both were achieved?
So the eyebrows are done with just a mesh that contains a bunch of hair cards. And the hair cards, they're all rendered with material that's using a shader graph that references the hair master node in HDRP. It's fairly standard pass-through affair. There's a couple of parameters, and all of these parameters, they map almost directly to the hair master node. There is no magic for making the hair look and render like it does. There is a little bit of magic, however, in making the hair move with the animation of the face. Because when the character animates, since we are doing the facial animation with 4D data, the mesh deforms, you could say, arbitrarily. So what we will see here is that the eyebrows have a skin attachment component on them, and they are actually attached to the face mesh. What that means is that when the project is running and the frames are ticking, there is a driver on the face that drives all of these attachments to conform to where the face mesh is. So the result of that is that the eyebrows, they move with the skin. The same is true for the eyelashes. Let me see here. They are attached in the same way, except that they are attached at the roots, and then they are maintained rigid. So every strand here is a triangle strip, and those triangle strips they get to stay rigid when the skin is moving with and therefore there is no shader magic or anything that we have done to render the hair. There is some interesting property of the hair master node that we use, which I can bring up, and that was actually very useful for us. So this is the hair shader graph, and the interesting property is use light facing normal. That's really great if you have some hair that's not necessarily facing the light, but you still want it to glow at the rim. And if you download the package executable, there are some lighting configurations where this is extremely apparent on the character. It's actually, the hair graph is actually not very interesting. There's some vertex coloring in here. That's actually not for the face. That's because we used it also for to support the fur on the jackets in the film, and we wanted to darken the, those cards of fur towards the base of where they meet the jacket.
Awesome. Thank you so much for showing that for us. I would love, work actually at the halfway mark, so I think it's a perfect time to talk about our second package, our VFX Character package. Adrian, there, I love the Morgan character. There's so much going on there. And it's not just one visual effect graph, right? It's several visual effect graphs working together to create this single incredible character. Can you tell us more about that workflow of using multiple visual effect graphs, for a single character like Morgan? In fact, better yet, maybe why don't we take a look at the package and actually see what's inside it, and then you could tell us more about kind of those kinds of workflows.
That sounds good. All right, so this is the Morgan package that you can download from the asset store, and it contains the character and a small animation. It's actually the animation that we have in the Heretic, but just we cut it differently there. So yeah, I mean Morgan, it's been quite a roller coaster ride with this character, but it was super fun to work on. Let me just give you a bit of background of how we started. So when I joined the demo team, and I got introduced a bit to Morgan, like the character had some specific story elements, like it had to morph between a few shapes, and actually maybe I should show this. So it needed to morph between this, let me move maybe in a brighter spot. So it had to morph between a white and dark version, but also between male and female kind of body shape. It had to lit up with fire at some point, which is this. So it had a few, pretty well-defined requirements to tell the story. But it wasn't that well, but the appearance wasn't that well defined. We had a few concept arts made by our former colleague Georgi, but those didn't really get into the whole effects and transitions and all that, which I thought it was a pretty big part of Morgan. So I had a blank slate almost to work on him, and then reimagine him a bit, or her. So and that was fun. I started with some tests in Houdini, but quickly became apparent that having to simulate things in DCC, import it to Unity, see how it looks, then go back to DCC, do some changes, and all that, like all that back and forth, it was just not well suited for the kind of iterations that we needed. And I said, okay, let's give it a try. Let's give the visual effects graph a try. And then back then it was in alpha, I think, and then pretty bare bone. But it showed some good promises. And I have a short clip with some of I don't know how well this play over Zoom, by the way, but these were just some very early tests that we did, and Morgan evolved a lot. Like we had a few major iterations and things like that. Let me just kind of like this one, but it was a bit unstable for what we needed, and then this showed up. Like just it was great to experiment with the VFX graph and then try different things. So I can like again, and you mentioned at some point that Morgan is made of a lot of effects and there's a lot going on, but actually kind of the opposite happened. Like we had to restrict ourselves quite a bit because it's so easy to make a lot of stuff happening with the visual effects graph, and Wes, our creative director, was great at focusing on the important things and kind of prevent me from adding all the things that I thought it would look cool. So, but still, it was great to experiment, and like a lot of these things didn't make it into the final movie, but they actually gave ideas for other effects. So yeah, and this is the package. Yeah, just a quick run through the package. So the basic idea with Morgan was that I wanted to have something that not only played in real time, but it would allow us to author the character in real time. And what I mean by that is you're in the final shot with the final camera, the final lights, the final post effects, and you can change how the character looks there, and you can see the results and the impact in the final version of the shot. And that's for me that was a pretty good first step into real time authoring. So like let's say in this case, I could open the appearance settings and go to body calm and change stuff like the color, and you see like everything applies real time, it still plays and all that. But it's not only the color that I can change. I can change the mesh that's making up the body. I have some test meshes here. Oops, I clicked in the wrong spot. So again, I'm not sure how well you can see, but it actually changes the meshes of the body. So this was pretty nice, being able to iterate together with our creative director Wes and with our artist Paco. That was pretty nice because we were able to do these changes on the shot on the spot there. Yeah, which was just pretty nice. There are about, I think, 300 options that you can go and change, and yeah, like you mentioned before, the graph is like Morgan is made of a few graphs. They're actually around here, so we can count. I think there's about 17 different graphs making up the character. They're split into different graphs just to make it easier to work with. And what paid off was creating this custom editor interface early on, because it just saves so much time when you can aggregate all these options there and then change them faster rather than opening the graph, changing stuff there. So it was an upfront cost that definitely paid up in the end. Same with the debug options, actually. They don't want to show. Not sure. But anyway, like being able to debug a few things was great. Yeah, I don't know why they don't show up here. So yeah, this is Morgan. Some stats about the particles, how many we have alive. It's also nice to keep a bit the performance in check.
Nice. I'm curious, could we take a look at one of the visual effect graphs? Do you have any of them open?
I don't have them open.
No worries.
And
it'll take a bit to load, and we only have a few minutes. Yeah, it's and the reason why I mention it is because I love visual effect graph for so many reasons, but it's, for folks who haven't tried it, what makes it really interesting is it's a visual node based tool, and this project has different effects achieved in different ways. Like Boston, the bird that flies around in the Heretic, is more of a code based visual effect, whereas Morgan is created with these visual nodes. I think you touched on it to some degree already, Adrian, but if you could like explain more, like what that process was like, any kind of tips and recommendations when working with visual effect graph for complex characters like this to folks here. We'd love to hear more.
One of the things is it's great to work with the visual effect graph, but it's so easy to overcomplicate things. Like for example, exposing parameters. I can go, like I said, there are 300 here. I could expose 3,000, but that doesn't really mean that it's going to make the the process any easier. So for me, it's a balance of what you want to expose in the main interface, if you want to call that. So it's always a trade-off. It's easy to go in and expose things, and I would recommend to start with the minimum and add things as you require and as you find out that, I often change this parameter. Then let's expose it, let's make a nice interface for it, because, it's something that's going to save time. But I wouldn't go ahead and expose everything upfront, because it's just going to drown you in options. So that's one of the things. Subgraphs are great. Subgraphs allow you to encapsulate a bunch of nodes in there. So they are great, but there's a catch to them, and maybe that's going to be fixed at some point. But the catch is that so in this case I have 17 graphs, and let's say I have one subgraph there that it's used in all of them. So if I change something in the subgraph, it's going to recompile all the graphs, all the 17 graphs. And I said, they're a bit heavy, that's why I don't want to open them at this point. So it actually takes a few minutes for everything to update. That's why I prefer to take things out of the subgraph, do some changes in one main graph, see that it works, and then apply the changes to subgraphs. But subgraphs are pretty great for that. I love using sliders for the different effects here. I think they're a bit more intuitive and fun to use, and a bit more, let's say, artsy or organic. But of course, there are also some limitations to them. Related to this VFX graph itself, one of the things that I really like to use are animation curve, sample those over time, because it allows me to, let's say, learn between two parameters, not only linearly, but actually do it in a more controlled way, where you can have some built-in ease-ins and ease outs and all those things. So I'm using those everywhere. The animation, like sampling different animation curves, just to give a bit of a different feel to the transitions. So one of the main benefits of the visual effect graph, but also one of the requirements, I would say, to make complex characters is, to make your work a bit easier. Well, what I mean by that is, for example, this parameter, the more VFX. I mean, it's one slider, right, that I'm dragging here. It goes from 0 to 1, but behind it actually drives about 20 parameters. There are a lot of changes happening. There are these particles spawning and all that. So aggregating these things into simple commands, let's say, it's again something that's worth doing. And of course, it requires a bit of balance between complexity and accessibility, but it's worth paying attention to. And this balance between how flexible you want to make it and how easy you want to do it is something that usually you should keep in mind when you deal with any kind of effects, especially things that other people might want to jump into it and use. So as much as I could, I tried to keep a nice naming convention, or naming, not necessarily going to the technical thing of what that does behind the scenes, but actually what it looks like it does on screen. So just aggregating these things, and then most of these sliders do more than just one thing. But it's been pretty powerful to be able to tie them together in a nice interface as this.
Awesome. I definitely want to leave time for a Q&A as well. And I'm so sad that we lost the original Q&A panel from the first kind of part of the Zoom session. So folks, if you have any questions to ask Adrian or Lasse, please use the Q&A panel in Zoom down below. I will do my best to recall the ones that were asked in the Q&A panel previously, but if you posted a question, if you could repost it, super appreciate it. Again, folks, these packages are now available to play with the Digital Human package and the Visual Effects Character package. We'll share a link for where you can find those shortly. Let's see, there was some questions before about hair, or you can use the chat function as well if folks have any questions to share there too.
I remember that one of the questions was if we have used any streaming, because it seems like there's a lot of data. And I can answer that one. For starters, we have used streaming. We have used streaming for the facial animation data on the human. If you want to dig deeper, you can search for native frame stream in the Digital Human package. And that will get you some leads on how we are doing it. Basically, there is an async read manager in Unity that you can use to stream data in efficiently into memory.
Has the Heretic been tested to run on consoles? If you could discuss like that, if you tried it, because they were just curious about.
I can try to answer that question as well, though it's really a question for the tech leader of the project. The time being, the Heretic does not run on consoles. As we talked about earlier, we have for the entire project, there are still customizations to some of the packages. So bringing those customizations along with us as it's being upgraded to newer and better versions of Unity. That's taking up quite a bit of the time, which would otherwise be able to be spent on platform work. The key learning thing there for us, I think, is that customizations cost a lot of time. And thankfully now stuff in HDRP is improving in that aspect. We have more extensibility features that allow us to do less intrusive changes. I know that's all off on a tangent on the answer to that question, but I think it's
not at all. And we have some more questions coming in now through the Q&A panel. So we have a question for Adrian. How do you work on making all these effects working together? Do you start one by one? And when do you put them together?
So that was by far the biggest challenge was what came first, the tech or the visuals, and kind of being so codependent. You had to advance a bit with one and then advance a bit with another and advance a bit with one and the other. And, if you had an issue like a creative blockout or you didn't know how to solve a technical part, like the whole thing kind of stopped. So that was tricky. I would say just take it step by step. Luckily, it is real time. It is easy to experiment. It is fast. You don't have to wait for hours of simulations. So you do get that freedom. It could be maybe a bit too much freedom, but it's also we're in a real time domain. So why not make changes in the last minute before the release? But it is a challenge. I don't think there's any like perfect solution to that. It's something that any creative task deals with. You just have to start, and luckily I think it's a nice workflow. Being able to see things and react in real time. It's a nice workflow to get over that creative, and then, like I said, just build it on top of each other. Don't try to tackle too many things at the same time. That was another problem that I dealt with at the beginning. So just try to do this stack thing where you build both the visuals and the tech. But yeah, it's a challenge when these two are so interconnected.
Another question: what is the best way to start developing my own visual effects for a custom character?
Just start doing it. now, today. No, but seriously, just start. Of course, references always help. Like if you have, I mean, as abstract as things could be, most likely somewhere someone did something similar. You could find a reference somewhere in the movie that you can tweak and make it your own. At least to start it, right? And it is such an organic process that even though you start with something that might look similar to another artist's work, because it's such an organic thing. It just builds on top of each other, and in the Heretic, that was definitely the case. Like I said, we had so many effects that were cut, but we had so many others that were intended for one thing, and then they kind of became different. Like the hair that I'm showing here, like this helmet that I can change. This started as actually some experiments for the face. Like I was looking for some sort of detail, and then it just looks like something that might resemble a helmet, could be nice, and then I made it bigger and bigger, and at some point it was something like this, and now it got to something a bit more decent. But it is an organic thing, and I would say don't be afraid. Start working on it, and yeah, it's fun.
2 more visual effect graph questions. Could you tell us, please, how do you transfer animated vector fields data from Houdini to Unity? Are there any extensions for that?
We don't use animated vector fields. It's just a static vector field. And there is a tool developed by the Paris team, and it's available to download, and that allows you to export vector fields from Houdini to Unity. Like I don't know if the question was related to how we keep the characters on the mesh, because that's something that Unity doesn't support at this point. So like the simplified answer is that we're rendering the position, the normals, and tangents in UV space, and then we fed that into the VFX graphs, and we position the characters on the mesh. And my colleagues Robert and Torbjörn did some great things on the package to optimize that process and make it a bit more streamlined and not stitched together as it was during the Heretic. And I think you guys that are going to download the package are gonna have a much better experience with this part of how we keep the particles on the character and make it follow properly.
All right. One more modular. How modular are visual effect graphs, and can we take out components of the visual effect graph to use on our own projects?
Oh, for sure. Yeah. I mean, you can. There's standard VFX graph nodes. You can merge them into a subgraph and take that out. You can. I don't know how the subnodes, the other parts, I don't know how they're called technically, but you can do that as well. You can take everything, you can replace this mesh with something else. Like it needs to have a few properties. Like we're using vertex colors a lot to drive the some of the properties. Like around the hands, for example, we needed the particles to be a bit smaller than they are on around the fingers. I mean, to be a bit smaller than they are on the rest of the body, just because there's more like tighter curves there, and you want to carry the details to be just a bit smoother so you can read the fingers. And it's the same for the nose and lips. So around those areas, the particles are denser and smaller. And we use vertex colors for that. So I think the vertex color red controls the size of the characters. And if you see this character in the vertex color, which you should be able to see under debug, but it doesn't work. But if you do that, you'll see that there are some, the character has some vertex, some red painted around the face and around the hands. But, you can take things and use it in your own project. It should be pretty straightforward.
Absolutely. Thank you, Adrian. And I think that's kind of like the best part of this package. Like, feel free, folks, to not just use the package to look at how things were made, but taking all those bits of it, the stuff that Adrian showed, the stuff that Lasse showed, take the pieces that you're interested in, modify them, use them in your own projects. We'd love to see what you create. That's all the time that we have for today, though, at the moment. That being said, you can still ask us more questions if you have any by visiting our Q&A link that we have listed here. So this Q&A link, bit.ly Heretic QA. You can learn more about the Heretic from this link here as well. We also have links to the Digital Human package and the VFX Character package that you could download if you haven't yet to try out these packages. Feel free to hit us up on the forum with more questions. Thank you so much for joining us during this session, and thanks for your patience with the technical difficulties. Again, we'll get this all recorded and edited and posted up on YouTube. And really, that's kind of it for us. Thank you so much, everyone. Have a good Unite Now.
Bye, everyone.
Bye. Thank you.
Bye, everyone. Thank you.